Hello everyone, welcome to this video series on cryptography and network security lab. So today we are going to look at program 10. So before that, like and share the video and subscribe to my YouTube channel for notifications on latest videos. So the program 10 is actually about implementing RSA algorithm. Okay, so when compared to all the algorithms that you have seen until now, RSA is somewhat different. So RSA is uh, called public key algorithm. Okay, public key algorithm, or you can also say RSA is asymmetric algorithm. So you already know what is the meaning of symmetric algorithm, right? So for encryption and decryption, if you are using the same key, that is called as symmetric algorithm. If you are using different key for encryption and decryption, that is called as asymmetric algorithm. Okay, which is also called as public key algorithm. Okay, right, now let's see some important points about RSA algorithm. So it was introduced or developed in 1977 by three people called Ron Rivest, Adi Shamir, and Leonard Edelman. Okay, so you can see how it got the name RSA or SA. Okay, so as I already told you, RSA uses or utilizes two keys. One is private key, another one is public key. Okay, so the user has to first of all generate two keys, that is private key and public key. So the private key is always kept secret. It is not shared with anybody. Only the user who created the private key has it, and public key is shared with everyone. Okay, it is available for everyone, and we can actually do encryption with either of the keys. That is, you can use public or private key for encryption, and for decryption you have to use the other key. Okay, right. So the RSA algorithm works like this. So first we have to select two large prime numbers p and q. Okay, and then in the next step you have to calculate the value n, which is equal to the multiplication of the numbers p and q. Okay, so this n will be used as modulus. Okay, so the RSA algorithm mainly depends on the prime factoring and also modular arithmetic. Okay, so this n is going to add as modulus. We will see. Okay, so after calculating n, you have to find a number called e, which should satisfy this condition. That is, e should be greater than 1 and it should be less than phi of n. Okay, so the symbol is called phi, phi, phi. Okay, it's called a totient function. Okay, right. Now one another condition is e should be relatively prime to phi of m. Okay, e is relatively prime to phi of n. Now what is the value of phi of n? It is calculated like this: p minus 1 into q minus 1. Okay, so after calculating phi of n, you have to find the number e such that it is prime to phi of n. Okay, once you find e, if you take e comma n, that is e and n together, that is your public key. Okay, you will share this public key with everybody, whoever wants to communicate with you. Okay, now once you got the public key, you can do encryption. So like this. So C is the ciphertext, and here M is the plain text message. So one thing I want to tell you is the plain text, that is the input for RSA algorithm, is numeric. So the letters will be converted into numbers. Okay, so this m is some number which is raised to the power of e. So e is the thing we just calculated, and then after raising m to the power of e, we will do modular arithmetic with the modulus m. Okay, so the result will be the ciphertext, which is also a number. Okay, now once you calculate the ciphertext, you will send this ciphertext to receiver, right? Now I told you how to calculate how to calculate the public key. Now the other thing is private key. So for that, we have to calculate something called D. Okay, so E for encryption and D for decryption. You can remember it like that. So we have to calculate D. So how to calculate D? You can use this formula. Okay, so K can be some number. You can substitute some value of K such that you will find this value, right? So you must get an integer. Okay, it should not contain any decimal point. It should be an integer. Then once you find this D, you can combine D and N together, which is called your private key. Okay. Now, how will you get the plain text? So you take the ciphertext, raise the ciphertext to the power of D. So D we just calculated now, and N we already know the modulus. So the result of this gives your plain text, the original M. Okay. Now let's see an example, working example for this algorithm. So first step is calculating or finding P and Q, some prime numbers. Okay, so I took two prime numbers, 7 and 11. Next step is calculating N, which is P into Q, that is 7 into 11, which is 77. Then you have to calculate or find the number E, which is relatively prime to the totient function, which is phi of n, which is given as p minus 1 into q minus 1, which is 6 into 10, 60. Okay, and one number relatively prime to the 60 is 7. So this is my E. Okay, so E comma m, which is 7 comma 77, is my public key. Okay, once we find the public key, we can encrypt that by using the formula m power e mod n. So let's say m is 9. So the plain text number or character is 9. So we raise 9 to the power of 7 and we do modulo 77, we get 37. Okay, so this 37 is the ciphertext that we send to receiver. Okay, and now calculating the private key, that is you have to find D using this formula. So I substituted the values. Phi of n is 60 and E is 7, and by trial and error I found out that for k is equal to 5, D is 43. Okay, so the D I got is 43. Now if you combine D and N, which is 43 and 77, that is my private key. Okay, now once you get the private key, you can find the plain text again by using this formula. Okay, so C is 37, D is 43, and N is 77. By solving this, we will get the original value 9. Okay, so this is how RSA works, right? So as I told you, RSA is based on factorizing or factoring large integers, the two prime numbers. Okay, so in the example, I took P and Q as small numbers, 7 and 11, but in reality, the numbers will be very large. Okay, the number might contain 30 digits, 40 digits, and so on. The numbers will be very large. So an attacker cannot guess the values of P and Q. q. Even brute forcing the values of p and q is very time consuming, right? Okay, so p and q are selected randomly, and of course they should be prime numbers. So you can see here the values of p and q are kept secret. They are not shared with anybody. Okay, only the value of n and also e is shared with everybody, public key. Okay, and again the private key is not shared with anyone, right? So finally, the different applications of RSA where this public key algorithm can be used or asymmetric key algorithm can be used is it can be used as a digital signature, right? And it can be used as a digital certificate, and also it is used in secure communication protocols like transport layer security and virtual private networks, VPNs. Okay, so RSA is a very important algorithm which has real world applications, and that's it about RSA. I hope all of you understood how RSA works. Thank you.